Okay, welcome everybody. This is antiderivatives. So we know how to take a derivative. Now we will find an antiderivative. And with that being said, if you can take a derivative, the function must be continuous. Same goes for an antiderivative. To find an antiderivative, the function must also be a continuous function. Okay, so besides all that, since you don't need to know that, the symbol, that curvy little symbol, right? It says we state it as the indefinite integral. So we say the integral of f of x dx. This means we're going to find the antiderivative of f of x with respect to x. So we write the integral of f of x dx is equal to capital F of x plus c. This is only true if you can check your work by taking the derivative of the antiderivative and getting back to the original function f of x. The symbol is called the integral sign. So where am I? Right here. So this symbol is called the integral sign. The function inside is called the integrand. The symbol dx indicates that the anti-differentiation process is performed with respect to x. So we would say we are taking the antiderivative of f of x with respect to x. And that letter c over here, this is an arbitrary constant. It is called the constant of integration. So no matter what integral you take, you will always add c. So it'll always be the antiderivative plus c. Okay, let's get into some antiderivative formulas, right? Some antiderivative formulas. And the first one, let me zoom in a bit for you, is probably the most important one. This is the power rule for antiderivatives. So remember derivatives, the power rule, you took one away. For antiderivatives, you add that one back. So this is the most important rule and probably the rule you'll use the most. So you can call this the power rule for antiderivatives. Okay, and then 2, the antiderivative of e to the x is, guess what? E to the x plus c. 3, the antiderivative of 1 over x is the natural log of the absolute value of x plus c. 4 is the constant rule. It says if you have the integral of k times f of x dx, then you can take this value of k and just move it to the outside of the antiderivative of the integral. Okay. 5, the integral of multiple terms. So the integral of f of x plus or minus g of x dx can be split into multiple integrals. The integral of f of x dx plus or minus the integral of g of x dx. So however many terms are inside your parentheses, that's how many integrals you can have. Okay, and then number 6, we can call this the constant rule. If you're taking the integral of a number, of a constant, then the antiderivative is kx plus c. So this can be called the constant rule. Okay, with that being said, let's go ahead and get started on finding these antiderivatives. Taking an integral and finding an antiderivative. Okay, so first one up is the integral of 7dx. 7 is a constant. which means this will use the constant rule. Okay? So the integral of 7 dx is 7x plus c. That's it. That's the antiderivative. How do you check your work? Take the derivative of this function. If I say, all right, this is now f of x equals 7x plus c, then f prime of x is just 7, which is there. Because c is the constant of integration, and what's the derivative of a constant? 0. And what's the derivative of 7x? 7. That's how we check our work. Take the derivative to check your work. Okay. Next one, number 2. The integral of 8x dx. So we are going to use rules number 4, which means we're going to take the 8, move it to the outside. And then we are going to use the most popular rule, power rule, number 1. So let me walk you through that. So first, let's rewrite the integral. 8 times the integral of x dx. Now, all we have to do is take the integral of this, x dx. The 8 waits outside. So next is power rule. So you'll get 8, and I'll put brackets here to be neat. And now I will use the power rule above, number 1. So the power of this x before is 1. So this means that by the power rule above, I get x to the 1 plus 1 over 1 plus 1. So this is power rule. Now, let's clean it up. You get 8 times x squared over 2. Multiply it. You get 8x squared over 2, or 4x squared. And we are done. Do not forget to add the c. There it is. Okay, so check your work. What is the derivative of 4x squared? The derivative would be 8x, right? F prime would be 8x, which is right there. There you go. That's it. Okay, let's keep going. do it again on 9x squared. Okay. So first thing I'm going to do is take that 9, move it to the outside. 9 times the integral of x squared dx. Now all we have to do is take the integral of this part, x squared dx. The 9 waits outside. So 9 times, and again, power rule. X to the 2 plus 1 over 2 plus 1. Once again, power rule. Okay. This now becomes 9 times x cubed over 3, which gives me 9x cubed over 3, or 3x cubed. We are done. Don't forget the plus c. And once again, check your work. What's the derivative of 3x cubed? That would be 9x squared. Which is right there. Okay. See? Not bad. Antiderivatives are easy. Okay. All right. 4. This one's just going to be strictly power rule. So you get x to the 5 plus 1 over 5 plus 1. This becomes x to the 6th over 6. That's it. We're done. Plus c. Not bad, guys. And once again, power rule. Okay, perfect. Let's keep going. 5, same thing. 5x to the negative 3 dx. Once again, power rule. X to the negative 3 plus 1 over negative 3 plus 1. We get x to the negative 2 over negative 2. Again, all right. Clean this up. I was checking the way my math lab likes the input, and it actually likes the negative exponents for now. So all I want to do with this one is bring the negative up. So I can make this negative x to the negative 2 over 2. This is great for my math lab. It should be great. But if you want to be greater, then you could rewrite this as negative 1 over 2x squared. If you want. You don't have to. The first one I box is perfect. That's what my math lab will take. I saw it. A bunch of answers yesterday had negative exponents. It was at midnight, though, so who knows? Okay. All right. Oh, yeah. What do I call this little circle? I say or that's what that's called. Or you can be better. But I don't know if my math lab will accept that one, so go with the one that I box. It's good that I show both, so you know how you can rewrite them. Okay, 6. Boom, zoom in more, how's that? Okay, there you go, okay. Okay, perfect. First thing we're gonna do is take the 10 out. Ten x cubed to 3 has dx. Where all we have to worry about is the integral of this part, which again is going to use the most popular rule, power rule. So the 10 weights, bracket for neatness, x to the 3 halves plus 1 over 3 halves plus 1. Once again, power rule. Okay, and then this 3 halves plus 1 I change in 1 to a fraction of 1 over 1. I get a common denominator of 2, which gives me 3 halves plus 2 halves, which gives me 5 halves. So that's where we're going next. Equals to 10 times x to the 5 halves over 5 halves. All right. How do I move to the other side? Let me see. There you go. That's better. Okay. And now we must take this part and flip it, reciprocate it. So your next step is this equals 10 times, when you flip it, the 2 comes to the numerator. So you get 2x to the 5 halves over 5. Okay. Multiply the 10 in there. You get 20x to the 5 halves over 5. But 20 over 5 is 4. So we get our final answer of 4x to the 5 halves plus that lovely constant of c. There it is. All right, let's keep going. Okay, 7. All right, 7. I'm going to rewrite it. First thing I'm going to do is take that 3 out. I'm going to take the 3 out. So this becomes 3 times the integral of 1 over z dz. So this is the only part we want the integral of. And for this one, we're going to use the rule. One of the rules. That's going to be rule number 3 right there. 1 over x dx equals the natural log of the absolute value of x plus c. So that's what we're going to use here. So this one, I'll write that rule down. The integral of 1 over x dx is the natural log of the absolute value of x plus c. So this means that this becomes 3, bracket for neatness, times the natural log of the absolute value of z, and then this just becomes 3 natural log absolute value of z done plus c. Okay, there it is. That's it. Easy, right? Just follow the formulas on the paper. That's it. Like I always say, follow the formulas, and you'll be all right. Number 8. (16e to the u). So the first thing I'm going to do is move the 16 out. 16 times the integral of e to the u du, where I only need the integral of this part. So the 16 hangs outside, bracket for neatness. And for this one, we're going to use number 2. The integral of e to the x dx is still e to the x. So down here, there it is, 16. And we are using the integral of e to the x dx is e to the x plus c. So this becomes, the integral of e to the u becomes e to the u. And multiply that. You get 16 e to the u plus that lovely value of c. And yes, c always goes in at the very, very end. Okay, there you go. Let's keep going. Okay, number 9. Stay right there. Okay, number 9. First thing we want to do, distribute the 5. You get the integral of 5x minus 5x squared. Dx. Okay. We now have 2 terms inside the integral. This means that we can have 2 integrals. So this becomes the integral of 5x dx minus the integral of 5x squared dx. Okay? Well, now on both of these, I'm going to take out the 5 on both of them. I mean, we could have done that in the very beginning, but the work could have looked a little confusing. So I waited till now to take them out. Okay, so this means when I rewrite it, I'll have 5 times the integral of x dx minus 5 times the integral of x squared dx. Okay, and now all we need to worry about is the antiderivative of this part of x and the antiderivative of x squared. Okay, so let's begin. And you'll get, and it's going to be power rule on both of these. So you get 5 bracket x to the 1 plus 1 over 1 plus 1 minus 5 bracket x to the 2 plus 1 over 2 plus 1. All right, let's clean up. And we will get 5 times x squared over 2 minus 5 times x cubed over 3. Okay. Now, final answer is 5x squared over 2 minus 5x cubed over 3. And all of this plus c. Only one value of c. There you go, guys. Okay. Now, number 10. We have a lot of rewriting to do before we get to this antiderivative. The first thing we need to do is, well, the method we have to use is take that square root of u, bring it to the numerator. So, first thing we're going to do is rewrite it. I'm going to have the integral of du over u to the 1/2. Right? Remember that? Square root of x is x to the 1/2. Okay. So now, the next thing we're going to do is flip it to the numerator. So this becomes the integral of u to the negative 1/2 du. U to the negative 1/2 du. So what we used here was 1 over x to the n equaled x to the negative n. So all the rules we know already. We're bringing them back again. Okay. Now we are ready. We're doing the antiderivative of this guy, which is going to use the most popular rule. It's going to use power rule. So it's going to be u to the negative 1/2 plus 1 over negative 1/2 plus 1. And then once again, do the fraction work on this. Negative 1/2 plus 1. That's negative 1/2 plus 1 over 1, which I'll get a common denominator of 2 over 2. Add them, and you get a positive 1/2. So, my next step is rewrite it as that. U to the positive 1/2 over positive 1/2. And just like on one of the previous examples, you'll take this and do what with it? You will flip it. Reciprocate, it's the right word. But it's so much easier to say flip. Who do they want? Flip. Okay. So if I flip this, the 2 goes to the numerator, and you get 2u to the 1/2. Now, this one, I am not sure if my math lab will take this form. I didn't look at the rational exponents, but this one can be finished like this. Let's say it doesn't take that format. Then the last way to rewrite it would be as 2 square root u plus c. So this one could be my math lab. If not that, then you'll use that one. Okay, there it is. That was fun. Okay, again, number 11. Perfect. So once again, a lot of rewriting on this one. The first thing I'm going to do is take out the fraction. And when I say fraction, the fraction you see here is 1 over 4. So I'm going to take that out first. So my first rewrite will say 1/4 times the integral of dx over x cubed. And then the next rewrite is to take that x cubed and flip it to the numerator. So we'll have 1/4 times the integral of x to the -3 dx. All right. And now, all we want is the integral of x to the -3 dx, which means that the 1/4 stays outside, bracket for neatness, and we apply the power rule. X to the -3 plus 1 over -3 plus 1. Simplify. You get 1/4 times x to the -2 over -2. Now, multiply the fraction, and you'll get x to the -2 over -8. Okay. I don't like negatives in my denominator, so I'm going to rewrite it as -x to the -2 over 8. And this one is done. Plus c. That should be good enough for my math lab. But remember, you can always be better and rewrite this as -1 over 8x squared plus c. Okay. Perfect. Perfect. Moving along, moving along. All right. More to go. All right. 12. All right. 12. It's going to take some manipulating as well. We don't know how to find the integral of a fraction like this just yet, or maybe never. This is business calc. So what we're going to do is split this into two fractions, because we see that the two terms in the numerator are over the same denominator, which means I can split them into two fractions. The integral of 4 over u plus u over u du. So that's all I did. I split them into two fractions. Okay, now I'm going to simplify before I split this into two integrals. I will get the integral of 4 over u du plus, oh, I'm already splitting it into two integrals, my bad. Nope, I said I would simplify first. So this becomes the integral of 4 over u plus 1. du. Because u over u is just 1. There you go. Okay. So now I will split it into two integrals. And I'll have the integral of 4 over u du plus the integral of 1 du. Okay, and now we just want to find the integral of these two parts. Okay, so with that being said, one more rewrite, because on the first one, I can take the 4 out. So this will become 4 times the integral of 1 over u du plus the integral of 1 du. Okay. So the first one is going to use the natural log antiderivative. So this one looks like the integral of 1 over x dx, which is the natural log of absolute value of x plus c. This one is just the antiderivative of a constant. So this one follows the integral of k dx, which would be kx plus c, of course. So, with that being said, I get 4 times the natural log of the absolute value of u plus the antiderivative of 1, or the integral of 1, with respect to u, is going to be u. Me, no, u. Okay, and we're basically done. This becomes 4 natural log absolute value of u plus u plus c. As in C, senor. There it is. Okay. Perfect. There it is. Now, 13. Okay. Okay, here we go. All right, so I assume we're getting better at integrals now. So I know you can split this into 2 integrals, but I'm not gonna do that now. I'm gonna speed run this one because we should be used to it now. So, to start with, what's the integral of 5e to the z gonna be? The integral of 5e to the z is, guess what? 5e to the z. Plus, what is the antiderivative of a constant? What is the integral of 4 gonna be? Well, that is just gonna be 4z. And we're done. Harmless, painless, nice. Don't forget to add your c. Super nice. All right, perfect. So we were able to get away with on that one. 14, no, we can still get away with it. So first, we need to do some rewriting. And we need to do rewriting on this term, the 2 over x squared. We can't find the antiderivative in that form. So When I rewrite this, I'll have the integral of 3x squared minus 2. And what you're going to do with that x squared down below is flip it, right, to the numerator, which means you'll get 2 times x to the negative 2 dx. Okay. Perfect. Okay. And yes, now, like I said, there's 2 terms in here. I can split into 2 integrals, take out the 3, take out the 2, but we're over that. We know how to work integrals now. So like I said, let's fast track this. So let's focus on the first term, 3x squared. So if I'm going to take the integral of that, you already know the 3 is going to be outside. And we are going to power rule that x squared, which will become x cubed over 3. Okay? First term's done. Now let's look at the second term. 2x to the negative 2. So that's going to be minus, the 2 is going to wait outside, and again, you will power rule. Add 1 to negative 2, and you'll get x to the negative 1 over negative 1. There it is. That's by power rule. So now you see how fast we can work these. Well, how fast I can work these, okay? Okay. So, cleanup time. Guess what? Oops. I'll leave that dot up there. Okay. So guess what? This 3, that 3, cancel. We're left with x cubed. And now, this negative and that negative, negative over negative, will become positive. And what you're left with is 2x to the negative 1. And we're done. Just don't forget to add C. And no need to rewrite this one. Not bad. Okay. 15. So again, we have to manipulate this to get into the form we want. We don't know how to take the integral in this form. We can't find the antiderivative in that form. So what we do notice is that these 2 terms are over the same denominator, which means split them into 2 fractions. So you'll get the integral of 2x to the 4th over x cubed minus x over x cubed dx. Now simplify. This will become the integral of, so 2x to the 4th over x cubed, that just becomes 2x minus x over x cubed x over x cubed becomes 1 over x squared, or x to the negative 2. So that's what goes here. X to the negative 2 dx. Okay. We are ready for the antiderivative. Which means that, again, I can split it into two integrals, but we're done with that life because we know how it works. So let's just focus on the first term, 2x, and that becomes 2 times, you will power rule that x, and that will become x squared over 2 minus. Now let's focus on the second term, x to the negative 2. Power rule that, and you'll get x to the negative 1 over negative 1. Now, clean it up. This 2, that 2, cancel. You're left with x squared, and once again, this negative over that negative makes positive. So you'll get plus x to the negative 1. We are done. Plus c. That's it. Let's move on. Do it again. For the one right below. 16, just like the last one, split it into two fractions. X to the 5th over x to the 4th minus 2x over x to the 4th dx. Simplify. You get the integral of x to the 5th over x to the 4th is x. And then we'll take a peek at this one. $2x over x to the 4th becomes 2 over x cubed, which becomes 2x to the negative 3. So this will be minus 2x to the negative 3 dx. Waiting for the computer to catch up. Sorry. Any day now, broski. Any day now. Go, 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 go. Boom. There you go. Okay, so 2x over x to the 4th became 2 over x cubed, which became 2x to the negative 3, which I put in my integral. Okay, so we are ready. We know we can split it into two integrals, but we're done with that life. So I will first focus on the first term, x. So you will power rule that one, which will become x squared over 2. minus. Now we focus on the second term, 2x to the negative 3. This will be 2 bracket. You will power rule x to the negative 3, which becomes x to the negative 2 over negative 2. Simplify. This remains x squared over 2. All right, so what happens here now is that this negative 2 over that negative 2, they cancel and make positive. X to the negative 2. We are done. Plus C. Okay, there it is, guys. Again. Number 17. Split it into 2 fractions, just like we've been doing. There we go. Equal to the integral x squared e to the x over x squared minus 2x over x squared dx. Simplify. You get the integral. These x squareds cancel, leaving you with e to the x minus, and again, let's take a peek at 2x over x squared. Which means that this becomes 2 over x, which we will leave as that, 2 over x. So if we ever just have an x by itself in the denominator, just x to the power of 1, never rewrite it as this. Do not write as that. Because if you take the antiderivative, it's not going to work out. So always leave it as 2 over x. Okay. All right. We are ready. So let's focus on the first term, e to the x. We're going to look at e to the x. Well, that one's easy. What is the integral of e to the x? What's the antiderivative of e to the x? Well, that's e to the x. Now let's look at the second term, 2 over x. This one is going to use, remember, the integral of 1 over x dx, which will be the natural log of the absolute value of x. So that's what that's going to use. So this means that the 2 waits outside, and you'll get 2 times the natural log of the absolute value of x. Okay, we're done. Rewrite it as e to the x minus 2 times the natural log of the absolute value of x plus c. Done. Okay, perfect. On to applications. I'm going to pause for a quick sec. Not stop recording. Let me see. Not pause share. Let me see. There it is. Pause recording. Okay. And we're back to recording. Okay, perfect. Okay. So we're on applications now involving these, because why are these useful to us unless we have an application? Well, here you go. Okay. So the marginal average cost of producing X sports watches is given by C bar prime of X. Yes, that's C bar prime. So C bar prime of X is equal to negative 1,000 over X squared, where C bar of 100 is 25. C bar of X is the average cost in dollars. Find the average cost function and the cost function. What are the fixed costs? So we have to answer all these questions. So the cost function we know is C of X. The average cost function is given as C bar of X is equal to C of X over X. And the marginal average cost function is the derivative of C bar of X. So C bar prime of X is equal to the derivative of C of X over X. So what we're given is the average cost function, the marginal average. So we're given the marginal average cost function, which means we need to find the antiderivative to go back to the average cost function. And then we just need to find a way to rewrite the average cost function as the cost function. So we are working backwards for this whole problem, starting with the actual derivative, the average cost function. So that's what we're going to do here. So first step is to find the average cost function. So we'll say step 1. Find C bar of X. That's the average cost function. Okay. So this means that to find the average cost function, we are going to take the integral of C bar prime of X with respect to X. Well, it's a good thing that C bar prime is given above in the problem, which means we get the integral of negative 1,000 over X squared dx. So this part is C bar prime of X, right? That's given from the problem. That's C bar prime of X. Okay, keep going. Let's find the integral to get us the antiderivative. But first we have some rewriting. First thing we're going to do is take that negative 1,000 out to the front. So this becomes negative 1,000 times the integral. And the next thing we're going to do is take this X squared, and guess what we're going to do with it? We're going to flip it. So you should have negative 1,000 times the integral of X to the negative 2 dx. Now we are ready for the antiderivative, which means we just worry about this part, X to the negative 2 dx, which we will power rule it. It's the most popular rule, which means we get negative 1 1,000 bracket. You power rule x to the -2, and that should give me x to the -1 over -1. Okay. One more step. This negative and that negative, negative over negative, will make positive. So we end up with -1,000 x to the -1 plus the constant of integration, c. This is now the average cost function. So this is now c bar of x. So the derivative, the antiderivative of c bar prime gave me c bar. But we are not finished because c bar is not complete. We must solve for c. So, coming back. We are looking for, we're solving for c in c bar. So should I make that a step? Sure. I'll say 2. Solve for c, the constant of integration in c bar of x. And it's a good thing they gave us another clue. The clue to solve for c is given at the top of the problem. We know that c bar of 100 is 25. So that's the clue we are going to use. Which means we're going to plug 100 into our c bar formula, our new c bar formula. Okay. So I'm going to rewrite the clue down below. The clue is c bar of 100 equals 25. So we know that c bar of x, so this is our clue, right? So c bar of x is what we just found. C bar of x is -1,000 x to the -1 plus c. So what we're going to do now is plug in this 100, plug it in for x. So we get c bar of 100 is equal to -1,000 times 100 to the -1 plus c. Okay, almost there. Well, type that in your calculator. -1,000 times 100 to the -1. Or another way to rewrite that is -1,000 over 100 plus c. It's the same thing. All right, which means that should just give us 10. So Another piece of the clue that we're going to use right now is that, well, C bar of 100 is equal to 25. So this C bar of 100 becomes 25. So that's what we're going to plug in for C bar of 100. So that becomes 25 equal to negative 10 plus C. Now solve for C, add the 10 over. We'll let the computer catch up. Come on, computer. So add the 10 over, and 35 equals C. So this means we have actually found C bar. C bar of X is now going to be negative 1,000 x to the negative 1 plus 35. So now this is the average cost function. Computer's being real slow today. Waiting, waiting. Negative 1,000 x to negative 1 plus 35. That's our new average cost function. So with that being said, this became that. Okay, now let's say if my math lab doesn't like that format, then one other way to rewrite this is negative 1,000 over x plus 35. Oh. I even said in the beginning, didn't I? That 1,000 should be positive, huh? My bad. So it doesn't change a lot. That's my fault. Negative over negative, still negative, huh? So easy fix right here. Oop, nope. Stop it. There we go. Which means that so the only thing that changes on here, since now that our 1,000 was positive, is that we don't get 35. We actually get 15. Bam, fixed. My bad. So that 1,000 should have been positive. Easy mistake to happen, right? Don't let it happen to you. Okay. Cool. So there's two. So there's the average cost function written both ways. Okay. So this means that our next step is to find average cost function, and then find the cost function, and then figure out what your fixed costs are. Okay. Cool. All right. So with that being said, 3 is going to be find the cost function. C of x. Okay. Cool. So from the above, right now what we're working with is C bar of x. So C bar of x puts the cost function over x. So what I'm saying right now is that we have C bar of x, which puts C of x over x. Which means what I'm going to do is that in order to get the cost function, I'm going to plug in our average cost function. And I'm going to do the fraction form. So my cost function from our above becomes 1,000 over x plus 15. And I'm going to set that equal to C of x over x. So this means that all I have to do to solve for C of x is multiply, well, first, I have to get rid of this x. So in order to get rid of that x, I will multiply both sides by x. That's all I'm going to do. So I'm going to say multiply this side by x, and multiply all of this by x. So when I do that, this x will distribute here and here to the 1,000 over x and the 15. Well, x times 1,000 over x just becomes 1,000 plus x times 15 is 15x. And over here, these x's cancel. And all we're left with is C of x. There it is. Now this is our cost function. So we have everything we need. The last thing to do is find fixed cost. So we'll make that step 4. I'll say down here, we're at right over here. 4. Find fixed cost. So remember, a cost function is made of a fixed cost plus a variable cost. Well, our cost function which is on the left, is given by c of x equals 1,000 plus 15x. So with that being said, our fixed cost is 1,000. And if it asks for it, your variable cost is 15x. That's it. And there you go. Sorry about the negative. So make mistakes too. And they're recorded mistakes. Whoa. Okay. So see how one little sign can ruin a whole problem? So just keep an eye out for that. Okay. All right. There you go. So that was work backwards, work backwards, work backwards. Okay. Last problem. Last problem. Okay. So, monthly sales of an SUV are expected to increase at the rate of S prime of t equal to negative 24 t to the 1/3 SUVs per month, where t is time in months and S of t is the number of SUVs sold each month. The company plans to stop manufacturing this model when monthly sales reach 300 SUVs. If monthly sales t equals 0 or 1,200 SUVs, find S of t. How long will the company continue to manufacture this model? Okay. So, first thing we're going to do is find S of t, which means they're giving us the derivative above. So, we're going to take the antiderivative to find S of t. So that's our first step here. One, find S of t. So that means we're going to set up the integral for S prime of t with respect to t. And S prime of t is given above, negative 24 t to the 1/3. So let's plug that in. So we'll get the antiderivative, or the integral, of negative 24 t to the 1/3 dt. So this part is S prime of t. Okay. Now, let's find the antiderivative. So the first thing I'm going to do is take out the negative 24. So, negative 24 times the integral of t to the 1/3 dt. We are now ready to find the antiderivative by taking the integral of t to the 1/3. And this will, this will be, guess what? Power rule. So you get negative 24 bracket, and I'll work this one out since it's a fraction, and y'all love fractions. T to the 1/3 plus 1 over 1/3 plus 1. Okay. So your fraction work, 1/3 plus 1, put 1 over 1, get a common denominator of 3, and this will give me 1/3 plus 3/3, which is 4/3. Okay. So what we have next is negative 24 times t to the 4/3 over 4/3. All right. Clean it up, because now, what are we going to do with this fraction? 4/3. You're going to flip. Okay. So I'll rewrite it over here. Or down here's fine. So this becomes negative 24 times, that 3 goes to the top, 3 t to the 4/3 over 4. Okay. Now, this 4 will become 1. This 24 becomes 6. We are left with negative 18 to the 4/3 plus c. And this is S of t, which means that we're not done. We now need to solve for, guess what? C. Just like the last one. So, 2, find C in S of t. Well, in order to find C, we must have been given a clue above. And that clue is right towards the end of the problem. When t is 0, there are 1,200 SUVs. That means that down below, my clue given is at S of 0, you have 1,200 SUVs. This is our clue. So, this means bring back S of t. And S of t is negative 18t to the 4/3 plus c. So just like the last problem, this means we're going to take 0 and plug it in for t. We're going to take 0 and plug it in for t. So we'll get s of 0 equals negative 18 times 0 to the 4/3 plus c. Well, that becomes s of 0 equal to 0 plus c. And now, using the clue, we know that s of 0 will become 1200. So plug that in for s of 0. So this becomes 1200 equals c. Which means that we can now complete s of t. S of t becomes negative 18t to the 4/3 plus 1200. There you go. That's S of t. All right. So one last thing to solve for. This says, the very last sentence says, how long will the company continue to manufacture this model? And the second sentence in the paragraph says, the company plans to stop manufacturing this model when monthly sales reach 300 SUVs. So the clue given there, so how do we word this? How long will the company continue to manufacture this model? So step 3 says, find time when S of t equals 300 SUVs. So find time when S of t equals 300 SUVs. So that's given above. So it says the company plans to stop manufacturing this model when monthly sales reach 300 SUVs. And then it says how long will the company continue to manufacture this model? So we are looking for time when we hit 300 SUVs. So this means that bring back our function, our formula for S of t. S of t equals negative 18t to the 4/3 plus 1200. And now what we're going to do is take 300 and plug it in for all of S of t. So plug it in for S of t, not t. T is time. S of t is the number of SUVs. We're looking for time, so we can't plug anything in for t. So 300 goes in for S of t. So you get 300 equals negative 18t to the 4/3 plus 1200. And now our job is to solve for t. So that means the first thing to do is move over the 1200. Minus 1200, minus 1200. Negative 900 equals negative 18 t to the 4/3. Then divide by negative 18. And 900 over 18 becomes 50. 50 equals t to the 4/3. Okay. So how do we get rid of that 4/3, right? How do you get rid of that 4/3? So I'm going to show you a nice little trick, right? So you don't have to rewrite this as a radical. Because normally, t to the 4/3 would be written as the cube root of t to the 4th. Where to get rid of that, you would cube both sides. And then that would lead you to t to the 4th. But then, you would have to get rid of the 4th power. So then, you would have to 4th root everything. Which would then lead you to t. But that's just too much work. So, I'm going to show you a nice little shortcut. Instead of doing all that stuff, which builds character, by the way, why not just raise both sides to the reciprocal power? So if 4/3 is my power here, I'm going to raise everything to the what's a good color? Yeah, I'll raise everything to the 3/4. I'll even raise 50 to the 3/4. Because when you do power raised to a power, the operation is multiplication. So that will become 4/3 times 3/4, which cancel, 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 leaves you with 1. Which means you are left with 50 raised to the 3/4 equal to t. And now, type in 50 to the 3/4 in your calculator, right? So I can do that by, let me see. There you go. Hopefully you're seeing my calculator. 50, raise it to the 3/4, or 3/4 is perfect because it's 0.75. Enter. And we get that t is 18.8. Okay. 18.8 what though? What does t represent in this whole problem? T is the time in months. So this means that in 18.8 months, they will stop selling those SUVs. And that's it. That is antiderivatives. All right, and of course, if my math lab said to round, then you would put 19. So there you go. Okay. That is it, guys. Fun stuff. All right. We're done.